In this video, we will see how to draw the polar plot. Let us consider an example. The example is we need to draw the polar plot for an open loop transfer function 14 divided by s into s plus 1 into s plus 2, as well as we need to determine the gain margin. So the given transfer function is this one. You need to convert this transfer function into the frequency domain. For that, put s is equal to j omega. So our transfer function will become g of j omega into h of j omega will be equal to this. So just replace s by j omega. Okay, so once this transfer function is found, you need to determine the magnitude and the phase angle of g of j omega into h of j omega. Here I am denoting the magnitude by capital M. So therefore, the magnitude will be here 14 is the real part. So the magnitude will be only 14. For j omega, real part is 0. Therefore, magnitude is omega. And for j omega plus 1, it is real part square plus imaginary part. Imaginary part is omega, so omega square plus real part is 1, so 1 square is 1 only. Similarly, for j omega plus 2, it is omega square plus 4. Now, after finding the magnitude, let us find out the phase angle phi. So, here phase angle phi is nothing but it is tan inverse of imaginary by the real part. Imaginary upon the real part. Okay, so here for the number 14 only there is a real part, imaginary part is absent, therefore tan inverse of 0 is 0 only, and the angles of the denominator terms when you take in the numerator they will become negative. So for j omega angle is minus 90 degree. For j omega plus 1 it will be tan inverse of omega divided by 1. So I have written it as omega only. For j omega plus 2 it is tan inverse of omega by 2. So once you find the magnitude and the phase angle, we'll prepare a table. We will calculate the magnitude and phase angle for two different values of omega. One is when the value of omega is 0 and one more is when the value of omega is infinity. So here for omega is equal to 0, so if you put omega is equal to 0, it clearly indicates that in the magnitude equation 14 divided by 0 is infinity, therefore we'll get magnitude as infinity and angle will be minus 90 degree minus tan inverse of 0, again here 0. So as we know tan inverse of 0 is 0, so the phase angle that we get is minus 90 degree. So therefore at omega is equal to 0, we'll get magnitude as infinity and angle as minus 90 degree. So let us calculate the same for when the value of omega is infinity. Okay. So now for omega is equal to infinity, if you put omega as infinity, magnitude will be equal to 0 and phase angle will be minus 90 degree minus tan inverse of infinity minus tan inverse of infinity. It will be 3 times of 90 degree, which is equal to minus 270 degree. Okay. So when the omega is infinity, magnitude you are getting it as 0 and angle is minus 270 degree. Let us plot this on the graph. So this is the real axis and this is the imaginary axis. Okay. At omega is equal to 0, magnitude is infinity, angle is minus 90 degrees. So infinity will start from here. Okay, and this is the angle minus 90 degree and this is the angle minus 270 degree. So this is the place where omega is 0 and magnitude is infinity. For omega equal to infinity, magnitude is 0. So here 0 magnitude, this point will indicate at omega is equal to infinity, and this one is for this angle is for omega is equal to 0. So it will cut the minus 180 degree axis, and this is the polar plot for this particular equation. Now let us see how to find out the gain margin. This is the frequency domain transfer function that we have written. Okay. Now let us rationalize this equation so that we'll get the real part of g of j omega into h of j omega and imaginary part. We will find out omega pc here. Omega pc is nothing but a phase crossover frequency. Okay. So when you rationalize this term, you'll get real and imaginary part. But at this particular frequency, g of j omega into h of j omega is purely real. That means imaginary part will be equal to 0. If you solve this equation, we'll get the imaginary part as 14 omega cube minus 28 omega equal to 0. Okay, here you can take 14 omega as common. You will get omega square minus 2 equal to 0. Therefore, omega is equal to square root of 2. This is nothing but a phase crossover frequency. Unit is radian per second. Okay, so once you find the phase crossover frequency, it is easy to find the gain margin. So what is the definition of gain margin is? It is equal to 1 divided by the magnitude of g of j omega into h of j omega when the value of omega is omega pc. We have already found the equation for the magnitude. This is the equation that we found. So let us substitute the omega as omega pc. Value is square root of 2. So if you substitute the value, you will get the gain margin as 6 divided by 14. Okay, and the value of the gain margin in decibels will be equal to 20 log of 6 by 14. So value that you will get is around minus 7.36 dB. As the value of gain margin is negative, therefore the system is unstable. Okay. In the next video, we will see how to calculate the gain crossover frequency and the phase margin for the same example. Thank you.